Hey y'all, Dr. Brown here again with another exciting histology video. This time we're going to be talking all about fat. In these very poorly drawn cartoons, you can see a unilocular adipocyte, or a yellow fat cell, up next to a capillary that would be running through this fat tissue. The primary function of adipose tissue is the storage of fats and then the liberation of those fats so that they can be used elsewhere in the body when they're needed. Fats are going to come to the adipose tissue in two main forms, either as a chylomicron, and these are going to be coming from the gut epithelia, so these are dietary fats that were absorbed primarily in the small intestine, and they're going to be packed up in these little carrier chylomicrons. So the inside is full of triglyceride, that's the fat that we're actually going to use, and it's being surrounded by a phospholipid monolayer that's then studded with lipoproteins. So those are dietary fats coming from the gut, but we can also have fats coming from the liver, and in this instance they're going to be in the form of very low density lipoproteins, VLDLs. That stands for very low density lipoprotein. These are similar in appearance, also being a phospholipid monolayer with a lot of lipoprotein, but in addition to the triglycerides, these have a lot of cholesterol in them as well. What we're going to do next is kind of zoom in on that area where the capillary passes right next to the adipocyte and look at how fats are going to get from the bloodstream, broken down, put into the adipocyte, and put back together. Let's zoom in, shall we? On the left we have our adipocyte, on the right we have our capillary, and rather than having the fancy drawings, I've reimagined the chylomicron as a green circle and the VLDL as a purple circle. I know, my artistic skills know no limit. Inside the capillary, we're going to find a membrane-bound enzyme called lipoprotein lipase. And lipoprotein lipase is going to open up these lipid droplets and break the triglycerides inside down into free fatty acids, which from hereafter are going to be illustrated as little blue squiggles. So those are the free fatty acids. And then also we're going to have glycerol. This is the 3-carbon organic molecule to which the fatty acids used to be attached. Now once those have been broken down, the fatty acids and the glycerol are going to exit the capillary into the extracellular space, and then they're going to go into the adipocyte, where they're going to be packaged back up into triglycerides again. So here's our little triglyceride molecule. We see our little brown E, that is glycerol, with 3 fatty acids on it. And here this fat will stay until it's needed again by some other part of the body. When that happens, the adipocyte will know that it needs to release fat because it will be bound by norepinephrine, represented here by a lightning bolt. Now, norepinephrine is going to be doing hydrophilic signaling. It can't come into the cell like, say, estrogen could. So instead, norepinephrine is going to bind to a surface receptor. It's going to activate the second messenger cyclic AMP, and cyclic AMP is then going to initiate the activation of the intracellular enzyme hormone-sensitive lipase, or HSL. HSL is then going to break this triglyceride back down into glycerol and the 3 fatty acids. These can then leave the adipocyte, make their way back into the bloodstream, but they're not going to be reassembled into triglyceride. The glycerol will be left free in the plasma, so it's just going to be fine. It can be dissolved in the plasma. But the fatty acids, since they're very, very hydrophobic, have to have some sort of carrier protein to get them through the aqueous or hydrophilic environment of the blood plasma. So the fatty acids are going to be bundled onto the carrier protein albumin. Now albumin does a lot of things for us. When we start talking about the cardiovascular system, we'll learn more about how albumin helps regulate the osmotic pressure of our blood. But for today's topic, we're really concerned about it as a carrier protein for our fatty acids. So they will stay bound to albumin until they get to their target tissue, where they will then be cleaved off of the albumin and be free to dissolve into whatever tissue they're going to. So that is fat lipid mobilization and storage in a nutshell. So I hope you've enjoyed. I hope you had a good time. I know I had fun making this little presentation. That's it for now. Study hard. See you later.